titles created yet. We're in a configuration, and in theory you could start working by placing things on the surface and patching, but really what we want to do next is build a title. So acknowledge, we're going to go new title, stick it in the training folder, we'll call it demo title, giant keyboard. Click it on there. Yeah, sorry, that wasn't highlighted, so type it again. There we go. Now it's going to go into the training folder and we create a new title, as you can see by the bar up there. As you see, the surface is completely blank. I've got masters on my control bay, so there's my 2 stereos and 4 mono aux masters, my 4 groups, my 1 master, and then the direct outs from the various channels we created. So, what do we do next? Well, we have no idea where anything is. If we go into General Patch and look at my input ports and output ports, there's no labels on them. We're in user label, but they just come up as generic names. Input 1, port 1, channel 1, through 768. And the same for the outputs, input 1, channel 1, through 768. So here is where we can toggle labels to our device labels, which are also completely blank, and then finally the fixed labels, which give us the system's report of what's in the system. So the system detected that there was a frame attached, detected what cards are in it, and wrote down or gave us the naming for these cards. So currently we've got a MADI card giving us 16 channels, a line input card giving us 8 channels, an AES card giving us 16 channels, and frankly nothing else is in there. So even though we've reserved all these spaces, there's no channels on them. Same for the output. We've got a MADI, a line out, an AES, and then nada. So the next thing we would do, and I'll sort of save you all the gory details, is we'd have to export the user label list that we generate from the fixed labels, and then with the aid of BEST and drawings and an Excel spreadsheet, we then start typing in the device labels, which we'd then import and stick into the user label field. We'd then transpose them into the device label field, making the user label and the device label identical. And then we'd export those again and then edit them in the spreadsheet so that the user labels become the user labels. Now, once we know where stuff is, we can start patching. So if these line inputs here are all my sources for my various, or first 8 or 16 mono channels like this, I'd patch them by, in this case sequentially, I'd just take the 1 through 8 and drag this sort of rectangle across the screen until I've lined up the range of channels I want to patch. And then you can either right click and click auto, or more satisfying is hitting the Mach Connect or Make Connect button on the surface, very Swiss. And there it is. So now we have the first 16 channels of the desk patched into patched into the I/O that supplies them with audio. Same for the stereo channels. We then have to go find our stereo channels, which start after the mono channels, and we'll use the remaining AES lines here that aren't being used up by the effects unit. And we'd have to go, if it's a stereo channel, this is left, this is right, because we're going from 2 mono input lines, these are individual mono channels from the AES card, into a stereo input. So this stereo channel patching is a bit more of a pain than the mono channel patching, because you really have to do individual patch points like this. And with that, I've patched 4 stereo channels. Now we need to do the same thing for the outputs as well. So we'd have to find our direct output ports. Remember, we never come off the bus because the bus is internally already connected. You'll see Busmaster 2 here, Busmaster 1 and 2, going into a master stereo. So these are 2 mono master buses creating a master stereo for us. Then we've got 4 group buses, which are making these patches automatically. And then you've got the aux bus patching, which happens here as well. So the bus output is the output of the bus, which does nothing but some audio, putting it into the output channels that give us access to a fader, to processing, and ultimately to a direct output, which is where we want to patch from in order to get our audio out of the desk and into the output converters. So we'd pick our direct outputs here, we'd pick our output ports here, and just to save everybody some time, we'll patch them sequentially like this. The master stereo output is obviously different. Now we're coming from a stereo row into 2 mono columns, so that's going to look like this instead. Then 4 mono outputs and 2 stereo aux outputs like this. And we're done patching. There's no more outputs to the system. What we've done in your case, though, is also define patch groups. So because you have so many inputs and outputs, we've gone up here and we've gone and permitted ourselves to edit the general patch so that we go in here, look at our input ports, find where our C routers are, for example, define them as a group of channels, and they can come obviously from different MADI ports as they do. You've got the odds on one, the evens on another, and then you've got the 3-4 channel extension on yet another MADI port or 2. But we all want them nicely sequential, so we can put them in here, edit this list, and then save that list as a new patch group, and we'll call it routers, for example, like that. That's great, but nothing's on the surface, so we have nothing to control at the moment. The next thing we do is then start defining what goes on the surface. I'm going to stick, in this fader bay, I'm going to stick the first 10 of my input channels that I've patched, and then we'll stick the stereo channels over here. Inputs, we'd have to find them. They're probably on the 2nd or 3rd group. There we go. And so now I have finally things on the surface, but they're not going anywhere until I route them somewhere. Nor are they, nothing's turned on, nothing's defined. Let's turn all our aux sends on these. So I'm going to set my faders here to unity gain. And I'm going to copy my faders to aux 1 through 4 like this. Copy paste, copy paste, copy paste, copy paste. So copy fader to row 1, 2, 3, and 4. Same thing over here. I'm going to grab these 4. Set them to unity gain by tapping the clear button and then tapping the cap of the fader. And then copy fader to row 1, copy fader to row 2, copy fader to row 3, copy fader to row 4, and there's my setup for my mix minuses on my auxes. If these are your routers 1 through 4 and you have defined aux 1 through 4 as being the mix minus for them, we have to remember to unlink and then do that. Same thing, for example, if you want to use the group buses for them. So we'd go ahead and turn all group buses on all 4 of them, like this, and then go and individually turn group 1 off, group 2, group 3, oops, group 4. Plus we want all of these to go to the master bus too, so I'm going to link all of them and assign them to my stereo master. Now I need to place my stereo masters on the surface, otherwise I don't have control over anything either. So we'll do that on the control bay. I'm going to switch to the control bay tab in strip setup. And what have we got here? I'm going to highlight this entire section 1 bay and put a master in there. Come on. There we go. My, how many are there? 6 auxes. And then on the page below it, we'll put our groups. Actually, tell you what, we'll keep the auxes and groups together. We're going to take the master and actually use a grandmaster position for it. That didn't work. There we go. Let's slide this one down. Whoop. So now we should have aux masters, group masters, master, 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 captain, captain, and we can link these, set them to 0, set our master to 0, and Bob's your uncle. So here would be a tiny setup. And that is how you start software config. Obviously, in the case of CNN, there's far more inputs. There's lots of things to test because of sort of the legacy of inheriting all the Euphonics I/O. There's a tangle of what's where. Oh, why is Enco 1 on channels 25 and 6 of this MA, but not on? It's all that fun stuff. So, getting that together. Bye, Herman.
Later, man.
Getting that together is half the battle. Once that's done, then you can start thinking about shows and show files and snapshots and, okay, how does my show start? What things do I need on the surface? How should they be routed? Should anything be tracked by default? I think the trans is by default. How do I want them laid out? I then generate my snapshot and my strip setup, which I can merge into the queue list, and then I have my show queue, which recalls both. Dead simple, really. So.
Nice. Get that rolling again. We are good.
All right. I'm going to wait for the title to load and grab myself a sound state. So, your question was, what kind of redundancy is there, and how do we initiate it, right?
Yes.
I'll be less of a slob and actually stand up to talk about it. There we go. Now, you got to understand there's two different sets of redundancies in this system. Should I look in the camera or should I look at you, Phil?
You can look at the camera.
I look at the camera.
All right.
I have no idea what that looks like. But, so there's surface redundancy. It is never an automatic failover on the surface. It is always going to be a user-initiated thing to some sort of crisis or perceived crisis. And the redundancy built into the surface is as follows. You have a total of 4 computers built in here. One of them runs your Vistonics panels and the faders and switches and knobs and does the graphics for that. And the other one is exclusively dedicated to drawing lots and lots of bar graphs on the meter bridge. Each of those is backed up by another pair that does the same thing. So by default, we're running on the main system, and we should have a look at this little section over here now in the power. The first 4 LEDs in a column here show us that all 4 computers are turned on. You can only access the video DVI output of 2 of the computers. You can access it for the main desk and for the redundant desk. So by main and redundant desk, they mean the Vistonics and faders. And then there's also the main meter PC and the redundant meter PC. All 4 of them are on. 2 of them I can look at via a DVI switch and an AB switch. So if I press the 3rd button down here, which is screen access main/redundant, and press the redundant button, it will show me that the redundant control system is in fact alive. And there goes a backup from the main right to it. We saw that little progress bar travel across the screen. Let's close this. That is the system surveyor. It's what keeps all 4 computers in sync. It's what keeps the main system's title backed up onto the redundant system, and it also tells them all to switch off when you get a switch off command. So we've established that the backup system is working. That's probably a good thing to know before failing over to something that might be worse than what you're working with. And again, to switch back to main, I'm just going to press this 3rd button down once, like that. So doing that just transferred keyboard, trackpad, DVI, and this little USB port over to the redundant system temporarily, and when I pressed it, they all came back to the main system. In order to change to the redundant system, and we'll talk about why later, if you can, if the system hasn't frozen on you, it is always best to exit cleanly if you can. Press the surveyor button, click Exit GC. This quits software after confirming that that's something you really want to do. The reason you want to do this is because if it's able to shut down properly, it writes so-called shutdown files. Now these shutdown files contain your last known settings. Very often if there's a crisis, those files won't be written because the software will have hung and you won't be able to access the menus, in which case skip the step I just showed you and do the following. If you're sure the backup system is up and running, press and hold the fourth button down here, which is the little Swiss flag. That's our redundancy button. Press and hold it until it lights up red. And now it's switching over to the redundant system. If we watch what's happening on the screen, not the built-in one but the external one, it is initializing the disk, and what it's doing during this process, and you'll see this flash a number of times, is it's attaching the screens that were once attached to the main system now to the redundant system. That's why it blinks. It's a USB bus. They're USB display drivers. As it discovers the devices on the USB bus, it re-enumerates them, and every time it finds another display, it goes, oh, I've got to re-enumerate myself, and blinks out while it does that. And that affects the main GC as well. So, as you can see on the Vistonics, before it vanishes, we're now on the redundant control system. This will load with the graphics any second. And here you are. So the redundant control system is up and running really the moment you see channels on the strips and fader meters. If you don't see metering on the meter bridge, that's not a huge tragedy. That always is slightly more delayed, but you have control the moment that you have graphics here, fader glow, and moving meters down on the faders. And the meter bridge eventually catches up too. And that's as easy as it, well, that's as hard as it is to fail over to the backup control system. Now, important to remember that this will never fix bad audio. If you have bad audio, switching to the backup system is not going to fix it, because the audio is not processed by any of the computers you've just changed out. The audio is processed by the signal processing cores up in terminal gear.
As despicable as
there's our audio being generated by one of them. How do we find out which one is active? Well, we'd have to go into the surveyor and look at our DSP cores. So I'm going to expand the Infinity Cores tab here, and I'm going to see we've got Decontrol Infinity Core number 1 and 2. Both are online. Number 1 is currently the audio master. If you are getting bad audio, or that core fails, if the core fails, it should switch over to the other one automatically. If you're getting bad audio, it may not be bad enough for the core to want to switch over. It usually will, but it may not. And to do that then manually, you do the following. So I'm going to quit out of here. I'm going to track some audio just for demonstration purposes. Now we're on the redundant system, so I don't have any shortcuts set up in the browser, nor do I have a shortcut to the browser even in the menu. On the main system we have shortcuts here. I'm going to run Google Chrome. Oh dear. Maybe we should do this from the main system, because that's probably the time when you'll be doing it. So anyway, getting back to the main system, my favorite way of doing that is to simply quit GC like this, and then shut down the computers. If you focus on this little section here while I'm shutting down, just do a traditional Windows shutdown, you'll see which computers have turned off. And they should ultimately all turn off, so that should be all dark. So at the moment, all 4 of them are on. You see the flashing of the big screen. That means, and then everything but the redundant desk computer is currently off. And we just wait for it to quit. And now none of them are on. So to turn the desk on, you press main on. You'll never, ever, ever press desk on to turn anything on. It's a button whose purpose is now, I think it's been made obsolete. I don't know if it ever had a purpose. It's there for firmware upgrades and things where you have to turn the Surface off but keep the computers in the desk alive. But for all intents and purposes, it serves no purpose for you as an operator. And in fact, we had a Vista 1 shipped back to the shop because they said every time I turn it on, it turns off again. And what they were doing were pressing first the main on, then the desk on. Perfectly logical. But what they were doing was turning on the computers and then immediately turning off the Surface while leaving the computer alive, which gave them the GC screen and a big error message that it couldn't find a Surface. So, anyway, while we're booting, you'll notice that this item here, this RTW meter, was also booting. It is in no way connected to our software. It's its own operating system. It's a standalone module that can be attached to any desk. It happens to fit nicely in the Vista V, so we specified it as the meter, or the de facto loudness meter on a Vista V. It's not even made by us. So, something interesting will happen here if you've been on the redundant section. First of all, it'll check for recovery data. It's done. It discovered recovery data. It's time-stamped as 8th of May at 14:59:30. It's initializing the desk. Once it's realized that all the fader bays and control bays that it wants to see are there, it's going to ask us a question. All right, we have two identical titles, one on the redundant system and one on the main system. Because I just mucked about for a little bit on the redundant system, I don't want to keep that data. I want to go back to the main system and discard the recovery data. Should you have been at a point where your main system truly failed and wouldn't boot, and you've been working on the redundant system for a week and made changes there that you wanted to keep, once the redundant system, or once the main system is back up and running, it will ask you this question, and you will want to answer, most likely, let's pull the redundant data over, and it'll copy the redundant system's data over onto the main system and make that the new defaults for the main, because you may have put changes in there that aren't going to be in the main system's recovery data. Plus, you may have corrupted the main system's data by virtue of it crashing. So it's a good thing to copy over something that we know is working. So I've, in this case, chosen the main system because we didn't do anything on the backup that's worth keeping. I'm going to confirm that we want to keep it like that. It cleans up the recovery directory and deletes the stuff on the redundant system, and then boots the software. Now, we were asking about, okay, what are we going to do if we have bad audio? As I may have mentioned, bad audio is never going to be fixed by rebooting the Surface. That is a waste of time and just a high-risk activity I'd avoid. At best, it's a waste of time. The system, as we know, was running off the main core and still is. And in fact, if we'd left a fader tracked, I should have done that, I guess, and had it coming out of a non-monitoring system, like not the control room speakers, we would have heard audio continuing to be tracked, so it would still be going to air. If we discover that we have bad audio, we'd like to remedy. On the main system, I've put a shortcut to Google Chrome in the Start menu. I've also, that needs to go. I've also got 5 tabs open. I'm going to close 3 of them. We know that it was the main core that was the active core. Sorry, I'm very distracted by volcanoes. Very interesting. But in order to force it over to the other core, is you could send somebody upstairs to turn the main core off, but that might take a while. You can simply go to the Infinity panel, make sure you are in fact on Infinity Core 1, like this. Go to Control, and I'm going to reboot the system. Now all this does is reboot this one core. So I'm going to click Reboot and confirm that that's what I want to do.
more than 1,000.
And the moment I
members in
click
the
OK,
past
it'll be
week.
on the backup
The
system.
majority are now centered around the Volcano Summit.
So now we're
miles
running
away
on the
from
backup
Fishers.
DSP core
What's happening
upstairs
on
while
Big
the main
Island
one is
truly a
rebooting. And in fact, if we look at
for
the
the nearly
surveyor,
2,000 Leilani estate residents who were
it's red.
forced to evacuate
And if we
their
look at
homes.
why it's
However,
red
they
by
are
double
now
clicking,
being given
we'll see that the
a
decontrol
daily
infinity
15-hour
core number
window
1 is
to
offline,
call
and
the
now
members, check on their
decontrol
possessions,
infinity
and
core number 2
investigations
is our
permitted.
audio
But
master.
those residents are the only people Hawaii's governor says should be even near that community.
And that's how you might
We
be able
are
to fix bad
asking,
audio.
Any visitors and residents.
There's nothing you can do if it's
stay
hitting the
running
converters
from
bad, of
the,
course, because that's beyond our domain.
The volcanic activity there.
So your question was, why would you want to switch the surface over? And I think the answer would be, if you are mid-show and the surface freezes up, that's probably a really good time to switch to the redundant system, or at least try to. If you are mid-show and the meters vanish, that might be distracting, but you still have functional faders. It's then a toss-up as to whether or not you want to risk switching to the other system or not, because if everything else is working, can you make do without your meter bridge? It's a little spooky, but you've got to weigh one risk with the other. Okay, is that going to fix it if I go to the backup system? You don't really know. If you get a blue screen of death on the main system, I would most definitely go to the backup system. No questions asked, as soon as possible.
And what's that process again? That's the holding the
Just
switch button?
press and hold
Say that
the
again?
fourth button down. Press and hold the redundancy button. That's the fourth button in this little cluster of system buttons. And that will automatically switch everything over to the redundant system, as we just did. So,
Nice. That's easy. That's simple.
yeah,
So it's just holding that redundancy key for
Yep.
that situation.
for that situation, exactly.
And can you explain what the other situation was? And
Bad audio, you mean? Or
the one where you went into the website.
oh, yeah.
Yeah.
So, in case I haven't mentioned it before, switching over to the redundant system on the desk has nothing to do with the redundant or the dual DSP system that's running upstairs. Zero relationship. One controls the other, and maybe if one isn't controlling it anymore, you might want to try the other main system. But if there's bad audio coming from, say, everything in the core, and not just a source, you might consider there might be DSP errors. And in fact, there are occasions when the DSP errors are numerous enough for it to trigger a red state on the infinity core. And say here I don't know where it would show up, somewhere down. I would say core state DSP errors, I think it would say. And this would go red, and the surveyor would go red. Occasionally it'll get into a state where the timing's off inside the core, and you might get the occasional glitch on the surveyor, but that's one that you cannot hear. And in fact, that glitch might last several microseconds to a millisecond. It's almost inaudible, and therefore not considered worth failing over for. By the way, once you've failed over, and one is in the bad state, without rebooting it, it will stay on that other core. One thing you might want to do as a weekly systems check is make sure that, first of all, both cores are visible in your surveyor. We've had it to where one's quietly dropped offline, somebody's rebooted the disk, it's stayed offline, and when something's offline, like a core, and we're thinking of changing this in the software, but if it's not discovered on startup, it thinks, oh, you must not want me anymore. It's, got very low self-esteem that way, and therefore it no longer shows up in the surveyor as being a problem. If you don't notice this, and you have a core failure with the only remaining core, then there's nothing to fail to, and that's when you have no audio, or bad audio. So as a weekly check, I would make sure that you have both cores present, and for the truly ambitious, I would go and switch over to the other core. Now, we know that core 2 is now the online core. We'll go back to the browser, look at Infinity Panel, make sure we're on Infinity Core number 2 by clicking Infinity Core number 2. The IP address, by the way, for number 2 is .43, whereas for the main one it's .42, because 42 is the answer to life, the universe, and everything. That's actually why the software designers designated it .42, yeah. Douglas Adams fans. And then go to control, and then you can do one of two things. So restarting the service simply terminates and relaunches the tiny, relatively, application that runs the signal processing within the core. Rebooting the system would actually force the core to shut down and reboot. But restarting the service will have the same effect as rebooting the system will do as far as which is the active processing core. So if I do this, we're now on the main core. And in fact, there, it's not there, it's loading. And it's back. There we go. Things with no graphics, they boot quickly. So, all right, so that's that.
Nice.
Soll ich es auf Englisch sagen oder auf Deutsch? Anyway, sorry.
How many languages do you speak?
1, 2,
Two.
2. Well, American as well, but not very well.
Oh, yeah.
So,
It counts. Maybe you should have a comedy.
anyway, so what we were talking about, we were saying, all right, when's a good time to switch over to the redundant control system? We discussed it a bit, and honestly, if you still have audio control, but your meter bridge has gone blank, the risk of going to the redundant system, which is going to take time, and is, though it's going to be successful 99% of the time, you might end up having that 1% failure where it doesn't switch over properly, or takes longer than you expect to get control back. Why risk it? In other words, if you can't make things worse, switch over. If you can, don't. You know, a blue screen of death with full loss of control in the main system, definitely switch over. Meter bridge went a funny color, shouldn't matter.
Perfect.